Hi, this is Jeff Spence, your Math 135 instructor for the Community College of Denver. I'm going to do some examples from section 6.5 where we're finding probability / area using the normal CDF. Now the book is going to show you how to use the tables. This is mostly a display about how to use the normal CDF to find probability and area. Now in yellow you'll see the normal CDF function takes the input left and right end to find area. So every area is going to have a left endpoint and a right endpoint as far as z-scores are concerned. So that'll give us the area in between those two bounds, the left bound and the right bound. Now to access the normal CDF, you'll see in red, you press second vars and it's the second option down, normal CDF. Okay, so the example in yellow, or sorry, in green, I'm going to show you how to do this one. So it says find the P stands for probability. So find the probability that we have z less than negative 1.76. So what we do is we draw the bell curve. That's a pretty bad bell curve. Let's try again. It's better. Okay, and in the middle, the z-score of 0 should go there because this is a standard normal curve, and this is on the z-scale. We want to find the probability that z is less than negative 1.76. So negative 1.76 is going to be over here on the left, just somewhere on the left. Doesn't have to be super far over. And the probability that z is less than negative 1.76 is this area. The chance that z were to fall in that region. Well, the thing about this is that the area goes off forever and ever to the left. That's negative infinity. In our calculators, we're going to use this symbol for negative infinity, E99. The E is our scientific E from the calculator. 99 just means a 1 with 99 zeros behind it. So when we have negative E99, that's our infinity for the calculator. So to do this, we go to second vars and pick the normal CDF. Do normal. I might run out of room there. Let's do it over here. Normal CDF, and what's the left endpoint of this area? Well, it doesn't. There's really no endpoint. It just goes off to negative infinity. So we're going to do negative key, which is by your 0 key, and then to access the E, you got to press second comma. Okay, second comma to access that E. Do 99 and make sure the negative is in front of that, in front of the E, and then our right endpoint is negative 1.76. Okay, we press comma, put negative 1.76 in, press enter, and if we round this to 4 digits, we should get 0.0392. Okay, so I'm going to do a couple more examples on the next page. Okay, for this example, we want to find the probability that z is greater than negative 0.58. Now remember, I have the normal CDF command up there. It's accessed by doing second vars. Okay, but to do this problem, it's really helpful to draw a picture. Z greater than negative 0.58. So we draw the bell curve. Gosh, let's try this one more time. Draw the bell curve. Put 0 in the middle. This is the standard normal distribution with z. 0's in the middle. So negative 0.58 is somewhere here on the left. Just put negative 0.58 and hash it off. And we want to find the probability that z is greater than negative 0.58. That means we want the area to the right of that number. Okay, now remember this area goes off to the right. The right end would be positive E99, positive infinity. So we pick normal CDF. We do second vars. Second vars, and do normal CDF of negative 0.58, negative 0.58, comma, E99. Press enter. And if we round that to 4 decimals, we get 0.7190. So one more on the next page. Okay, so for this example, we have the probability. We're asking for the probability that z is actually between two values, negative 1.52 and 2.35. So when we do between, we just put the number line up and put both values up. Draw the bell curve, put 0 in the middle, negative 1.52 over here, and 2.35 somewhere over here. We're looking for the area that's the chance that z is in between, so that's the area in between the two numbers. We pick normal CDF of negative 1.52 comma 2.35. Press enter, and if we round that to 4 decimals, we get 0.9264. Okay, so these 3 examples are how to show you how to use the normal CDF. First example, we had a problem that was less than. Remember some keywords for less than are at most, less than, or below. And that's where we find the z, we get negative 1.76, and we do the area to the left. So any areas to the left, we start with negative infinity, negative E99, to whatever that number is. Next one, area to the right, greater than. Some keywords for greater than are greater than, more, at least is a key one that goes off to the right. And on this one, we do the normal CDF of that number to positive E99. The last example is a between. Usually just the keyword for something between is just we use between. So there's no hiding that one. And on this one, it's actually one of the easiest ones we do. We just do the normal CDF of the left number and the right number, round our answer to 4 decimal places. And this is how you find area using the normal CDF. You can use this function or your table. It's optional, but more people seem to prefer the calculator method. Either way, you need to be able to find the area. Remember, the big difference between area and position. The position are the numbers on the bottom. That is z-scores, all in the purple. Position. Negatives on the left, positives on the right. Area is a portion of the total curve. So it's always going to be between 0 and 1. Always a decimal between 0 and 1. So if you're getting negative answers for area or probability, you're making a mistake. So keep that distinction in mind, and good luck.